All right, we are live. Good morning, everybody. I am Vino. I work as a developer advocate at Snowflake. And today we are going to talk about a very exciting and I guess a new feature that was announced yesterday. I know yesterday was a big day for the world of data engineers, I guess primarily Snowpark and Spark developers, because did you hear? Snowpark Connect for Apache Spark is now in public preview. Wait, what does this mean? Did you hear Snowpark and Spark together in Snowflake? Yes, you did. So, to talk more about what exactly this is, what does it mean, how can you get started, I have with me today two beautiful, wonderful guests who's going to talk all things Snowpark and Spark Connect and also Snowpark Connect for Apache Spark today. So, to that, welcome to the show, Shruti and Nimesh, who are the product leaders who've built this product, and we're here to talk about all things Snowpark Connect today. Welcome, Shruti and Nimesh. Can you take a minute to introduce yourself to the show?
Sure. Hey everyone, my name is Shruti. I'm one of the product managers on the Snowpark team and working alongside Nimesh on Snowpark Connect for Spark. We're really excited to be talking about this feature today. Off to you, Nimesh.
Hi, I'm Nimesh Bhagat. I head product for Snowpark. Snowpark enables you all to bring application code to Snowflake. I'm excited to be here today.
Awesome. I know, I feel like there are a lot of keywords being thrown around today. Snowpark and Snowpark Connect for Apache Spark. I feel like let's start with, what exactly is Snowpark for some of us who may be new to the Snowflake ecosystem. Like, do one of you want to talk about what is Snowpark?
Sure. Uh, Snowpark is set of libraries and execution engine. It enables you to bring your application code, Java, Scala, uh, Python next to data in Snowflake. So if you think prior to Snowpark, if you're a Python developer and you wanted to work on data in your lakehouse inside Snowflake, you would pull all of the data out of Snowflake. This is bad for performance, bad for governance. Instead, what Snowflake allows via Snowpark is to bring that your Python, Java, Scala code next to the data. You see the user code execution sandbox. This is where the code runs, but at the same time, any relational uh, work, which is your data frame, all of that is run by Snowflake's vectorized execution engine. So there are three benefits to this, right? One, no data movement. This is so much better. Second, it enables you to use Snowflake powerful vectorized engine. And third, it brings familiarity. As you see, we support a number of clients over here. Depending on the developer who you are, we like to meet where you are. So this is Snowpark in short.
Gotcha. I think this is very cool seeing all the different client support here. Like if you're an OG Snowpark developer, you want to use Snowpark data frames, great. We've got support for that. But you're somebody from the Pandas world transitioning to Snowflake. You have Pandas on Snowflake. And we've always had UDFs and stored procedure support, again, OG Snowpark developers. But now also, I guess we have Spark developers being able to run their code also through Snowpark. So this is super exciting. Like what you're telling me is that as a data engineer, I don't have to learn another, set of libraries and APIs. I could just run with whatever I already know, and I could still work with Snowflake. Why
That's
is
right.
it happening only yesterday, Nimesh? I needed this last year or a couple of years ago.
Yeah, let me take that. And we really, our mission is to meet where the developers are. That's our goal. Now, what happened? Uh, s- we have a number of Spark developers who were using Snowpark data frames who loved it. As you said, you have to be using a different client, not your Spark code as is, even though it was very similar. I think the innovation which Spark community brought with Spark Connect, we're starting 3.4, where you could decouple both client and the driver, Spark driver. This decoupling enables you to run them in separate machines, similar to what any database you would do, JDBC client running separately and a JDBC driver. So with this innovation, what Snowflake is able to do is customers and developers can use their existing Spark client, their code, and we work as a driver. Now, this decoupling enables us to bring Spark code to Snowflake, and this is the reason why we are at the right time now with this innovation in place to bring this to our Spark developers.
Gotcha. Yeah, I think that explains. And also, when you say because of this decoupling that we are now able to run the Spark code in Snowflake, is Snowflake running Spark now? Do we have a Spark cluster in Snowflake? Like, what is that like?
No, so that's not the case, we know. So what Spark Connect, as like to what Nimesh pointed out, enabled us was to, let you run your Spark client. So right, like you have your Jupyter notebook, you have your VS Code, which has, your PySpark APIs. Now using Spark Connect API, we are able to get that logical query plan and use Snowflake Warehouse to execute that plan, right? So what it's really doing is letting you bring your Spark code, but executing it on Snowflake Warehouse. So meeting you where you are, but with meeting you with the efficiency of Snowflake's engine.
Got it. That's very cool, though. It almost is like the best of both the worlds because then, firstly, I'm working with the familiar Spark APIs if I'm a Spark developer. But secondly, I don't have to think too much about the infrastructure or like optimizing my job, like tuning and whatnot and everything. I guess Snowflake takes care of it. Snowflake being Snowflake, bringing the simplicity there. That's very cool.
Exactly.
Yeah, our mission statement has been over here to bring Spark familiarity and couple with Snowflake simplicity. So how do you bring both those together? This is what we are doing today.
Awesome. And it's very interesting now because we have all these different clients that we support within Snowpark, right? How does a developer think about when should I use each of these, or like what's the right use case for me to think about for Snowpark Connect?
So I can take a stab at it, Nimesh. So let's say you are a developer who is, accustomed to using Snowflake tooling. We do support Snowflake notebooks, right? Snowflake notebook will be able to execute your Spark code, starting with Snowpark Connect. You just need to make sure that you're able to download a data frame processor through the artifact repository, which is available, and the instructions are available in the public facing documents. Now, if you're a developer who's using a tool like VS Code or a data scientist who's using Jupyter Notebook, you can do that as well. We have again the set of instructions out there. You will need to download a client package, install it in your environment, and with the connection strings change, enable the Spark Connect session, and then get going with your day-to-day logic, right? Then the third part is, if you're used to running batch workflows, right, like using something like Spark Submit or Airflow, we do support that as well. We have something called a Snowpark Summit, which is more wrapped around Spark Summit, and it helps you basically trigger your scheduled jobs, right? Like more of fire and forget jobs. So again, in summary, we are able to support your interactive jobs through Snowflake notebooks, through Jupyter Notebook, VS Code, and your batch jobs through Airflow, Spark Summit, Snowpark Summit, which is wrapped around Spark Summit. And also, you obviously, if you're using Snowflake notebooks, you have things like tasks to run them and orchestrate them as well.
Gotcha. Okay, I think that's very helpful as to like what are the different ways I could think about using Snowpark Connect. And I guess what we have here is also how it is built on. I think Nimesh already touched a bit upon this. And is there anything more that I should know in terms of working with Snowpark Connect and how it is being built on Spark Connect?
Couple of things to note around Snowpark Connect, just in general, is like obviously it's built around Spark Connect API, which we discussed. We do support bunch of third-party tools, Snowflake notebooks, and batch jobs processes as well. In terms of what APIs we support, right? Like that's one major call out we should do. We support Spark Data Frame, Spark SQL, and Spark UDFs. So you would ask me, Shruti, what is not supported? We do not support RDD streaming, right? Like all of these are not there in Spark Connect in general, or are being introduced as part of Spark Connect with 4.0. So it's an innovative product which is also undergoing through innovation. So we will definitely look forward to supporting some of that as we move in future.
Awesome. Yeah, I do definitely agree with you that, of course, this is evolving as a Spark Connect. So we would see more iterations of what the developers would need. And Yes, I think we talked about what exactly is Snowpark and what is Snowpark Connect and how it is built on Spark Connect. And if, say, I'm a developer and I have to think about different ways I could use it, say, like how does my existing code change? Can I just take my Spark code and just like run with it, or do I need to like modify it too much? Like what would that look like? The workflow of running a Spark code on the Snowflake, perhaps.
Yeah, I think it depends from workload to workload as well. The underlying problem that we are trying to solve is that the logic does not change, right? So you're able to execute your Spark code. And, with like some of these Spark code could be, just run with just a connection string change, right? Like as long as you can trigger the Snowpark Connect session. Some of this might need your reader writer to be changed, right? Like there are some data sources, for example, which we do not support, but a lot is already supported. So it really depend on some of these nuances. But overall, we have tried to keep it as simple as where you can retain most of your Spark code as is and are able to run it with minimal changes on Snowflake's engine.
Yeah, we support 90%, more than 90% of the data frame APIs with Spark Connect is made available, and we continue to increase that coverage. So you will see lion share of your data frame APIs which are being supported, and that code would not change.
Got it. I think that's helpful. And also, I think we only covered the data frame side of the world, right? Does it also mean like what about the other libraries around machine learning or like ML ops? Do we have support for any of that too?
So
Spark Connect in 4.0 has started supporting MLlib, and we expect on our roadmap to continue to evolve. Today we support, as Shruti said, Spark 3.5. As we go to Spark 4.0, we will continue to increase our coverage when it comes to other libraries.
Got it. Okay. So if I have to sum it up from what I'm hearing, so we have almost 90% of all the data frame APIs that are being covered. And then, of course, there is Spark SQL coverage as well. But currently, what is not covered is RDD and the MLlib and Spark ML space. And for the coding languages, of course, we have Python. And we will have Java and Scala coming up. And yeah, I guess in terms of Apache Spark versions, also we talked about, I guess, 3.5 and above, and I guess not 4.0 because we don't have those. They're just coming up too, right?
yes, so Spark 3.5 is specifically, where we have tested against because that's where Spark Connect went GA as well. So, we do encourage customers to be on that version just so that, we can make sure that their code is run as smoothly as they can. Having said that, Spark does not introduce breaking changes between 3.0 version and 3. Like minor version updates. So we should be able to run a lot of that code too. The nuances when you are on a pre-Spark 3.0 version.
Got it. Okay. And I know we touched upon the different pieces of how it works under the hood, but is there like a deep dive if one of you can take it? Like, how does Spark Connect for Apache, I mean, Snowpark Connect for Apache Spark work under the hood?
Sure.
Like you talked about, getting the query plan and running it in Snowflake, so we don't have to like, there's no Spark cluster living under the hood in Snowflake, but maybe if you could touch a bit upon that.
Sure, I can take a first stab and I'll let Nimesh add more around, like it as well. So, what we are doing right now is, we have the Spark Connect API, which is basically sending us the logical query plan. On our end, we get that query plan, we get a lot of your data frame code, Spark SQL code that you're writing. And then we are converting it into, or like we are transpiling it into an optimized SQL and running it on Snowflake engine. And as the picture loads, you can see there are a bunch of steps involved here, right? Having said that, in most of the testing that we have done, we have seen similar price performance that we saw with Snowpark execution engine as well, right? So the hops are not going to change anything around that. But in summary, the Spark Connect API sends us the query plan, we transpile it and run it on our vectorized query engine. And then Snowflake obviously has a lot of, like ways to optimize the query that you're running altogether itself. So, right, like that comes with the beauty of Snowflake vectorized engine altogether.
One additional thing I want to call out over here is, as you see in the bottom of the picture, Snowpark works with data, whether it's in Snowflake FDN tables, if it is on Snowflake's Managed Iceberg, support for unmanaged Iceberg coming soon, and also through external tables if your data is on Microsoft, AWS, or Google Cloud. If data sits there, so your data could be in variety of these places, and Snowpark can still continue to bring its magic to you.
Got it. I guess because now we talked about the different cloud providers, I also have the other question. Does this work in all cloud regions at the moment, or do we have restrictions around it?
No cloud region restriction. It works everywhere.
Awesome. That's perfect. So this is also very interesting. And I'm trying to like have a follow-up question from one of our audience who has, is the workload still distributed in the same way as traditional Spark? Does the data loading, partitioning, task scheduling, and distributed execution, all of that still happens on the back end in Snowpark? I feel you literally just went over it, but I thought it could use a little more, repetition too, because this is it's come up.
So the execution engine, so in a nutshell, as Shruti said, right, Snowpark takes your application code, converts it into SQL. The SQL execution engine of Snowflake is truly distributed. It is elastic, it's distributed, it's serverless, and it has vectorized engine. Now, all the complexities of your partitioning and how you distribute data, this is where Snowflake magic comes in. We do this under the hood so that you don't have to think about this on an ongoing basis. So yes, it is a distributed execution underneath, and Snowflake takes care of all of that magic for you.
Awesome. Yeah, I think one more thing maybe I want to tell them is that do not think of this entire feature as Spark living in Snowflake, but think of it more as literally taking the query plan that is from the Spark world and then like take this intermediate product that is query plan and send it to this vectorized engine that Snowflake is, I guess, what, almost a couple of decades of like work that is being gone into optimizing the Snowflake query engine, right? So use all of that highly performant and efficiency into running this query plan. So it's really just taking your existing code, like getting that query plan and then giving only the query plan to the Snowflake's existing highly performant optimal vectorized engine. There is no, although you're running Spark code, and the code is the only Spark component here, there is nothing else Spark about it, if I can say that.
That's right. And you're spot on, right? If you look at the engine, Snowflake engine has been in more than a decade working on petabytes of data in a seamless way. So if you think that compared to a Spark engine, we are vectorized, we are also distributed, and also the serverless component, you cannot take away sort of the advantages you get of being serverless. You eliminate your versioning challenges. uh, we have You can quickly run a query without having to bring up cluster. There is no cold start time. So all of those benefits are also present when you are running the Spark code on Snowflake.
Awesome. And there is another question which is around, I would want to think Iceberg because we already touched a bit about it. Can Snowpark Connect for Spark work when the data is not in Snowflake?
Yes. In fact, as part of our private preview, we had customers who were on, Snowflake managed iceberg, unmanaged icebergs. They had data in their S3. All of those scenarios were well tested. So as long as you are in a catalog link database or you are in because Snowflake is able to support managed and unmanaged iceberg tables, we pretty much are able to leverage again our engine to make it work with Snowpark Connect too.
Awesome. And I think there is one more question that's sort of going back to what we talked earlier about the whole query plan and how Snowflake runs the query plan. Is there a scope for a developer to really optimize the query plan, like in between before Snowflake runs it, like based on certain parameters, like partition column, or like I feel like at the end of the day, Spark developers, I'm so excited about really having that flexibility to optimize and tune my job. Do I get to do that here?
Yeah, Spark developers do a lot of work when it comes to getting the partition right, getting the right executors, right memory. You do not get to do much of that. We believe there are going to be workloads where Spark developers who really want to get every a bit of performance through this tuning, they will continue to run on Spark. But if you are someone who likes writing PySpark, writing Spark code, want to focus more on writing pipelines, bringing new use cases, this would be a right fit for them.
Awesome. Yeah, and I think there is another question about for large file handling, say like 500 gigs to 5 TB, can it automatically scale the cluster? And I feel like this goes back to the architecture question of I want to say there's no cluster and you don't have to like scale it up and down, but I will let you answer it.
Yeah, so in Snowflake, you pick a warehouse size, and each warehouse size has a certain number of nodes. And as your code grows, you can automatically the warehouse continues to scale with those nodes. So yes, you can run large amount of data over here, and that automatic scaling happens under the hood for inside Snowflake warehouse.
Got it. So at the end of the day, I do not have to worry about the cluster size or like, elastically moving it up and down.
Yes, the you do pick the Snowflake warehouse size, right? You pick small, extra small, large, extra large. That's the one decision you make, but rest of the decision is taken care by Snowflake.
Awesome. Yeah. And okay, this is an interesting question. Will RDDs be supported? Do we want to say it's in the future roadmap or what would it be?
Roadmap at this point. It's under works, but yeah, it's not supported as of now.
Awesome. And I think this is also something we may have covered, like the version, like which Spark version does it support?
So we do support Spark with Spark version 3.5, because that's when Spark Connect went GA. Having said that, most of your APIs would not change if you're built with Spark 3.1 of the Spark 3.0 version, so it should work fine. We have had customers who had like who were using Spark 3.3 and were able to migrate to Spark Connect, our version, Snowpark Connect version 3.5 as well, with minimal code changes. As long as you're not below 3.0, that you know version migration should have minimal effects on you.
Awesome. Okay. And I know we also talked a bit about how to use it. Like, say, if I want to get started, or like, what's the next steps for me? Like, how do I, in my existing data workflows, how do I think about, is this a good candidate? Should I try Snowpark Connect now? Like, how does the developer or data engineer think about this?
I think one of the ways to think about is what like programming language APIs are you comfortable with? As Nimesh walked through that slide, right? Like Snowpark execution is really becoming a platform for everyone. So if you're someone who's comfortable with PySpark, you want to do minimal code changes, Snowpark Connect is your option, right? Like we're trying to meet you where you are. And you continue to retain your Spark code investments as well. So that's how you should think about it, in terms of whether or not to use Snowpark Connect or use Snowpark data frames or use pandas, right? It really depends on where you're coming from. And how to get started, well, the documentations are out, but we would love you to get in touch with your account team, so that we can make sure that your workload has good coverage in terms of APIs, and we can get started from there.
Awesome. Okay. And I was going to ask, like, what are not the ideal workloads? Because sometimes, like, a great feature comes out and I get very excited. But tell me, when should I not consider, or like, what are the limitations, at least at the moment?
Yes. So anytime you have RDD, MLib, or graphics, right? Like these are not supported as of now, as we called out earlier in the discussion too. And also, if you're someone who's looking for, completely full API compatibility, because the underlying engine is not the same, there are nuances, right? Like where the entire compatibility will not be one to one. So we want to make sure that we are setting the right expectations there too. We have tried to reach as close to Spark behavior, as farther we can, and we continue to learn through our preview process. So we're working alongside with ton of our customers to make this happen.
Mhm. Awesome. And with that said, I have a couple more questions, but before I get there, I want to ask you, because sometimes because it's a new feature and I'm a developer very excited about trying out these new features, there are like I don't know what I don't know, but you've been working on this feature for so long. So if there are any gotchas or like some, I guess, best practices, tips and tricks, anything you want to tell developers before we get started on this.
Uh, in terms of gotchas, I think there are a couple of gotchas to be aware of, right? First, we said the API compatibility is not fully there. So if you run into a missing API, we have tried to cover the most common APIs. We get lots of information. The second one is sometimes you will see semantics mismatch. For example, a data type. So we try our best to mimic Spark semantics, but there you might run into situations wherein your semantics on Spark and what you're looking at Snowpark Connect might not be exactly same. In that case, again, raise that to us wherever possible. We want to provide as much semantic compatibility as possible. The third one I would say is that someone asked this question also, that around observability we do have, you could use Snowflake trails, Snowflake logs, you could use all of that in order to diagnose this, but we continue to improve our observability features over here to meet very familiar experience where you have with Spark right now.
Awesome. Yeah, I think it's probably we have a bunch of follow-up questions about observability and debuggability also, because when you work with Spark code, that's probably one of the critical but sort of non-functional requirement. And is there anything in particular that I should know about like the observability of it or like debugging how like a failed run and whatnot?
Yes. So today we do support like out of box feature, which is Snow Trail, right? Like which helps you understand how your code is running. Like it works for Snowpark. In a similar way, it's expected to work for Snowpark Connect as well. We do have a feature which we're working on, which pretty much gives you a job based view, which is under works right now, which is what most Spark developers are used to, right? Like I'm running a job whether or not it failed or not. And then what is not going to be available through this feature is what most Spark developers are used to, which is called a Spark UI, right? Because again, we are trying to abstract some of these, Spark UI related use cases where you go and observe your executors and whatnot. All of that is abstracted as part of warehouse. So you do have warehouse, like monitoring, which is available on Snowflake, but nothing below that level of abstraction. Nimesh, I'll let you add anything to it too.
Yeah, that's good.
Awesome. Yeah, I think I guess Snowflake Trail gives you everything you need, but then if you're looking for like a Spark like experience, the whole point of us doing this is that to make life simpler and easier for you. So we are abstracting away those complexities, and you don't have to really have visibility into that.
Yeah, look, we the authoring experience, you can use your notebooks. We have something similar to Spark Submit, getting close to Airflow operator. That's the authoring experience. The debugging, the client side failures, it's similar. Now, I think in terms of observability, we do have things on the roadmap which gives you very similar to your jobs UI, which makes it very easy for you to look at jobs level monitoring, failures, and troubleshooting. And we'd love to continue to get feedback from our developers where we can bring this familiar experience which is more Spark like to you all, and that's on our roadmap.
Awesome. And there is like one more question about the architecture again, I would say. For large files, is the file blocks distributed across the warehouse node's memory? It's more of like how the Snowpark vectorized engine works. I don't think it's related to the feature itself, but because you're all working on all things Snowpark also, I would let you take the question if you can answer.
Yeah, I think there are two parts to this question, right? Like, is the file distributed and is it across the memory? I think again, this is what I would say is that this is a great question if you're a Spark developer, you're trying to get the right memory sizing and trying to make sure everything is well distributed. What I would say is Snowflake does distribute all its data across. There is a shared storage, then there is compute pool, and this compute pools takes care of reading this large data, which is well distributed, and then processing for you. But you are not the one who is actively thinking about whether, hey, do I have the right memory size, right number of nodes for the given data size, and that magic is taken care of by Snowflake. Again, as I said, it might feel very different for some of the Spark developers who really have tuned this a lot. In the beginning, you might feel like, if you go to an autonomous car, that you did a bunch of things and you start missing some of this, but after first few iterations you get used to it, right? And that's the change which you will see when you start working on the Snowpark Connect.
Mm-hmm. I think, wow, okay, this is a beautiful analogy where you're saying, hey, I'm driving a stick, but you built me an autonomous car. But I say, hey, I really want to drive the stick. So you put a stick on the car, but it doesn't really have anything to do. I don't have to think about how the stick works under the hood because everything is taken care of. But again, to come to this one, right? I think when I'm working with Spark, I have this mental model of, oh, I have my Spark code and I have this cluster, like the infrastructure that I need to manage, and what should be the number of nodes I need, the memory size, and like, do I need to move the cluster size up and down? And the mental model itself has like two components. One is the whole infrastructure, and the second is just the code itself. But what you're telling me is that with Snowpark Connect, I do not have to think about the infrastructure and the mental model. Just think about the pipeline and the functionalities you want to build. And under the hood, Snowflake takes care of, like, Snowpark vectorized engine takes care of running your code more efficiently. Takes, it's distributed. Of course, all the goodness that comes with distributed systems are in there. But as an end user, as a Snowpark developer, I do not have to have the same mental model of, like, what is the infrastructure under the hood? What's the memory? It was getting distributed. Like, Snowpark takes good care of all of that. Is that fair to say?
That's right. Like one thing I would clarify is, yeah, the Snowflake engine, Snowpark does not have a specialized engine. It does the conversion, but the vectorized engine is a Snowflake engine, which has been baked for decade plus, which does all of this underneath. So if you go and ask most of our Snowflake data engineers who are using dbt and other SQL ways, they don't think about this on an ongoing basis, and the pipelines just work, right? The number of ooms we see on Snowpark are very small compared to someone would see on Spark, and this is the reason why, because we do all of this magic under the hood.
Mm-hmm. Awesome. And there is one more follow-up question, which is, can I bring my own jars, Python wheels, or Conda environments? If so, how are they, stored, secured, versioned inside Snowflake?
So we do allow customers to use custom wheels and custom jars. Though I should call out that we do not support Scala or Java at this point, but eventually when we do, the jars would come into picture too. With Snowpark Summit, so if you're a customer who's trying to deploy a workload with custom wheels, you can use Snowpark Summit. I will need to follow up on the second part of the question around how does versioning work, but I can respond back to the LinkedIn comment.
Mm-hmm. Awesome. And this is not a question, this is more a comment, but I really want to highlight this where one of our users says, Snowflake data engineers are very pampered. And I'm like, yes, sir, big time. So this is probably like one last question before we wrap up the session, which is, SnowConvert is already migrating Spark code to Snowpark. So how is this different from SnowConvert?
Yeah, so the way to think about this is, of course, if you want to use native Snowflake functionality, the Snowpark client is going to be something which will do. For example, the AI SQL capabilities which we provide, it will be available in Python, dynamic tables. So if you want to get to the Snowflake native functionality, then the Snow Convert or SMA will help you convert to the client which Snowpark supports. But if you want to use your existing code without having to convert, then Spark Connect is the right solution for you. So it depends on what you as an end user is looking to do, and the solution may vary.
Mm-hmm. Awesome. So at the end of the day, do I still want to keep this Spark code and just run it however I want to run it, but give me the output? Or do I want to convert the Spark code into Snowpark compatible APIs and then I run whatever? It's really, like, at the end of the day what I want to do, which I want to say is less work for data engineers. Use Snowpark Connect. You don't have to convert anything, but I guess it doesn't apply everywhere. So that's true. All right. With that, I think we are at the end of the session. That was a lot of questions from developers that both of you answered. It was so much fun talking to both of you. And firstly, before we wrap up, I want to take like a minute or two to really sum up what I understood as a developer, what Snowpark Connect for Apache Spark is, and why I should be excited today to go try out. But if I do want to go try out, I have some feedback. Hey, I don't see this API compatibility. And we also said we have 90% coverage for data frame APIs. Say if I really want a specific API to be supported, how do I get that feedback across to Nimesh and Shruti? Is there a way that I could, other than bombarding you on LinkedIn, maybe?
Well, that could be one of the ways for sure. I'll definitely be on lookout on my LinkedIn DMs, but please work with your account team to find, send us this feedback as well. And we are working on other channels to start accumulating this kind of feedback too. So please stay tuned.
Mm-hmm. Awesome. So, what is Snowpark? Do you want to give a one-liner?
Yes, Snowpark is a set of libraries and runtimes which helps you bring your application code to Snowflake.
Fantastic. And what is Snowpark Connect for Apache Spark? Same one-liner.
Snowpark Connect enables you to bring your Apache Spark data frame code, which is part of Snowflake, one of the clients of Snowpark. So it allows you to bring your Snowpark code next to Snowflake data.
Mm-hmm. Awesome. Okay. Firstly, if you want to work with Snowpark and you were an OG Snowpark developer working with Snowpark APIs, life is great. But if you're a Spark developer and you are already working with Snowflake for some of the other workflows, you want to run your Spark code in Snowflake, the easiest way to do today is to have the Snowpark Connect. What it would do internally is really take the query plan, run it under Snowflake's vectorized engine. Great. You don't have to worry about anything else. And this is supported for Spark versions 3.5 and above. And currently it supports Python. And this is available under all cloud regions. So if you do have this Spark workload and Snowflake workload together, go talk to your account team, explore this, come back to us, tell us all about it. And yeah, thank you so much for coming to the show. Everybody watching, thanks again for fantastic questions and comments. And thanks, Shruti and Nimesh, for taking all the questions and telling us all about Snowpark Connect today.
Thank you.
Thanks, everyone.